Hello, welcome to Chapter 6.2, Adding and Subtracting Radical Expressions. We have learned the simplifying radical rules. 1. The radicand has no factor raised to a power greater than or equal to the index number. 2. The radicand has no fractions. 3. No denominator contains a radical. 4. Exponents in the radicand and the index of the radical have no common factor. And 5, all indicated operations have been performed. So here we're going to discuss about the indicated operations. So adding and subtracting radicals. First, we must simplify each radical expression. Then, radicals must have the same index number and the same radicand. 3, add outside numbers together and the radicand remains the same. To simplify a radical by adding or subtracting, you must have like terms. Like terms are when the powers and the radicands are the same. So for example, the cubed root of 5 and 6th cubed root of 5 have the same radicand and the same index. Therefore, they can be combined. 2x square root of 6z and 5x squared of 6z can also be combined because they have the same radical, which has the same index and the same radicand. So for example, in this one, if we combine these two, we would get 7 cubed root of 5. And if we combine these two, we would get 7x square root of 6z. To add or subtract square roots, you must have like radicands, the number under the radical. So here, if we were to combine these two, just like I did earlier, we have square root of 2 plus 3 squared of 2. When we combine these, because they both have the square root of 2, we would get 4 square root of 2. Sometimes you must simplify first. For example, in this situation, it doesn't look like you can combine them, but if I simplify the square root of 18 and I look for the perfect square inside there, I find that we get 9 times 2, and the 9 I can pull out, and I would end up getting the square root of 2 plus 3 square root of 2. Together, I can combine them and get 4 square root of 2. So in example number 1, we're going to combine the square root of 3 minus 2 square root of 3 plus 4 square root of 5 minus 3 square root of 5. So let us go over to the whiteboard and work this one out. In example 1, we have the square root of 3 minus 2 square root of 3 plus 4 square root of 5 minus 3 square root of 5. Now, we see we can combine these two, and we can combine these two because they both are square root of 3, and we can combine these two because both are square root of 5. So that means 3 minus 2 square root of 3 will give us the negative square root of 3. And the next one, we have 4 minus 3, so that'll give us plus square root of 5. Reviewing what we just did in example number 1, we combined the like radicals, plus, and we got negative square root of 3, square root of 5. In example number 2, we're asked to add square root of 20 plus 5 square root of 5 plus 5 square root of 2. So now let us go over to the whiteboard and work this one out. So here we have the square root of 20 plus 5 square root of 5 plus 5 square root of 2. Now here's a situation where you have to actually do some simplification. So 20 I can simplify because there's a perfect square hidden in there, and that is 4. So 4 times 5 will give me 20, and that means that I can pull out the 4 and get square root of 5 here, and then I can add that plus 5 square root of 5, but in this next part, 5 square root of 2 remains. Now these two I can combine to get 7 square root of 5, but this one I cannot do anything with, so it just travels along until I get this as my final answer. I cannot reduce it or combine it any further. Reviewing what we just did, it looks like we can't combine any of these. So we simplify the radicals to see if we can combine. And we did. We simplified the square root of 20 and we find that it's 2 square root of 5, and we were able to combine the like radicals in order to get 7 square root of 5 plus 5 square root of 2. In example number 3, we're asked to simplify 3 square root of 20 plus square root of 150 minus 5 square root of 45. So let us go over to the whiteboard and work this one out. In example 3, we have 3 square root of 20 plus square root of 150 minus 5 square root of 45. So now what we're going to do is we're going to look for, because it looks like we have to, see if we can simplify this. So, well, I'm going to break it down. So I see 3, 4 times 5, there's my perfect square, plus 25 times 6, there's my perfect square, there's my perfect square from 150, and then minus 5 square root of 9 times 5, and here's my perfect square from 45. So now I see that I can take out that square, that perfect square, so it's 3 times 2 square root of 5 plus 5 square root of 6 minus 5 times 3 square root of 5. So now I have here, I have 6 square root of 5 plus 5 square root of 6 minus 15 square root of 5. So now the two that I can combine, well, I can combine these two because they have the same square root, and that means that I get as my final answer -9 square root of 5 plus 5 square root of 6, and that would be my final answer. Reviewing what we just did, we simplify the radicals, we rewrite using factors, and there it's rewritten, and then we combine the like terms, and we get -9 square root of 5 plus 5 square root of 6 as our final answer. In example number 4, we're asked to simplify 3 square root of 27 plus 75. So let us go over to the whiteboard and work this one out. Similarly for 4, I have 3 square root of 27 plus square root of 75. So now I look for those perfect squares hidden. And here I have 25 times 3. So that will give me 3 times 3, square root of 3, plus 5 square root of 3. And that will give me 3 times 3 is 9, square root of 3, plus 5 square root of 3. So after that simplification, we see here that we have indeed the same radical. And we can combine those two to get 14 square root of 3. Reviewing what we did in example number 4, we simplify by collecting like radicals if possible. So here we did that, and we continue, and we ended up with 14 square root of 3, and that was our final answer. In example number 5, we're asked to simplify 2 square root of 45 minus square root of 20. So let us go over to the whiteboard and work this one out. We have 2 square root of 45 minus 20 square root of 20. And again, we're going to have to simplify it to see if we can actually combine those two. So we have 2 square root of 9 times 5 from the 45 minus 4 times 5. So now we take out the perfect square, 2 times 3, square root of 5 minus 2, square root of 5, and that will be equal to 6 square root of 5 minus 2 square root of 5. And as you see, again, we have, by simplifying it, we found that we can combine these two, and we get 4 square root of 5. Reviewing what we just did on the whiteboard, we simplify by collecting like radicals if possible. So we did this, and we got finally 4 square root of 5. In example number 6, we're asked to simplify the square root of 5x squared minus 3 square root of 25x. So let us go over to the whiteboard and see how we could simplify this one. For the next ones, we're going to look for situations, or look at situations where there are variables. So in number 6, we have the square root of 5x squared minus 3 square root of 25x. So again, we have to simplify. That's why simplification is very important, because it's not obvious if we can combine these until we simplify it. So it looks like here's the perfect square in there, so we can pull out the x, square root of 5. And here we have 3, and we have the 25, and that's times 5, but we get square root of x. So it doesn't look like we can combine them any further, because this is a square root of 5, and this one is a square root of x, and these are different, and therefore we cannot combine them any further. Reviewing what we just did, in number 6, here we're dealing with variables. So just like with numbers, we have to simplify it. And this is what we did here. We simplified it based on what we have here. And we got as our final answer, x square root of 5 minus 15 square root of x. In example number 7, we're asked to simplify negative 2 square root of 25y plus square root of 36y minus 4 square root of 4y. So let us go over to the whiteboard and work this one out and see how we could simplify this one. In number 7, we have negative 2 square root of 25y plus 36, square root of 36 plus square root of 36y minus 4 square root of 4y. So here it looks like we do have to do some simplification to see if indeed we can find what we can combine and what we can't combine. So here we have negative 2 times 5 because of the square root of 25, so we have the square root of y. Here we have plus 36 is a perfect square also, so that's going to be 6 square root of y. And it turns out 4 is also a perfect square, square root of y. So now we have negative 2 times 5 is negative 10 square root of y plus 6 square root of y minus 8 square root of y. And it turns out in this one, all of the y's and all the powers are the same. So we have the same y's, same y, same y, and these are all constants. So therefore we can just combine all of these together to get negative 12 square root of y. Reviewing what we just did in number 7, we looked for all the perfect squares and separated them. So we were left with everything was in square root of y, square root of y, square root of y. And we saw that because we ended up with everything in terms of square root of y and we had constants, we were able to combine these terms in order to get negative 12 square root of y as our final answer. Thank you very much. I hope you enjoyed this video. Take care, be well, and goodbye until next time.